Okay guys, today we're going to continue with sequences. Yesterday we focused mainly on the arithmetic sequence, which we use these formulas here to find the explicit formula as well as the common difference. Today I'm going to focus mainly on the geometric sequence. So if you look at this first example, you can definitely see that it's geometric because it's multiplying by 2 every time. Or if we use this formula for the R, the common ratio, you can take the second term there and divide by the first term and you get 2. Third term divided by second term and you get 2, and so on and so forth. So as long as you have a common ratio there, that proves that it's geometric. So the explicit formula for the geometric is the nth term equals the first term times r to the n minus 1. So the formula for this particular sequence would be the nth term is equal to 4, my r is 2, to the n minus 1. It's that simple. And to find any term, if I wanted to find the 45th term, I could plug in a 45 for n, and that would give it to me. Okay, so the reason for the common ratio that we focus on dividing, like we did before, because sometimes you're given some more difficult numbers. So if you can't tell what the common ratio is, you can take a term and divide by the previous, multiply by the reciprocal, and I'd get a negative 12 over 18, which simplifies to negative 2/3. So that's my R. Okay, so let's find the explicit formula and then find the 100th term of this sequence. So the nth term is equal to 5. My r here is 2 to the n minus 1. So the 100th term obviously it's going to be a really big number if you look at the sequence. So the 100th term, I've already done it for you in the calculator. You get 3.169 times 10 to the 30th. So we skip number 4, it's basically the same thing. Now for that formula, I'm going to come down here to the geometric formulas. Same as yesterday, you can take that nth term and you can set it equal to a sub m times r to the n minus m. Remember that the reason we're subtracting 1 there is because this is the first term. So you can use that to find, different terms. Let's see if we need that for the second one. I'm sorry, for number 5 here. Well, maybe not. We're finding the first 3 terms. Given the 10th term and the 11th term, we can find our r by dividing those. If I take the 11th term and divide by the 10th term, I get a 1/4. So if they're asking for the first 3 terms, I can take either one of those. So let's take the 11th term. And I'll just solve for the first term. So let's come up here. We get 5 equals the first term, 1/4 to the 10th. If I divide by 1/4 to the 10th on both sides, that gives me a first term of, let's see, I've already done that for you as well. It's 5,000,000 242,880. When you get an answer like that, you always want to look back at your sequence and just make sure that makes sense, is a reasonable answer. So the 11th term was 5, the 10th term was 20, so as I move to the left on that sequence, it should be multiplied by 4 each time. So you can see that I'm going to get up to some very large numbers there, so that does fit. The second term, if I divide that by 4 and multiply by 1/4, I get 1,310,720, and then a third term there would be 327,880. Nope, I'm sorry, 680. Okay, example number 6 here. Now this is one where I can use that formula, it looks like, with the N and the M. So if I take the 6th term, set that equal to the 4th term times R to the 6 minus 4. So 6250 equals 250 times R squared. Divide by 250, which would be 25. So that gives me an R of 5. So if I'm going to find the second term, again, I can use either one of those. So I'm going to use the 4th term. So we'll say that 250 equals the second term times R to the 4th term minus second term. So 250 equals a squared, I'm sorry, not a squared, a sub 2, second term, times 5 squared, and then divide the 25, and we get a 10, is our second term. Okay, last one I wanted to show you is, these are some really cool little shortcuts that will help you out. But anytime you see a sequence where your terms switch off, negative, positive, they flip back and forth, these little rules will help you out. If the odd terms are negative, then you need to include -1 to the n, and just put it out there like a coefficient. Just put it out front. And if the even terms are negative, then you can add one of these. Not add, but multiply one of these into the formula. So, what I like to do is ignore the negatives. So for the first term, I get a 2. For the second term, I get a 5. Third term, I get a 10. Fourth term, I get a 17. So after you figure out what the pattern is, which would be n squared plus 1, because my first term is negative, my third term is negative, my fifth term is negative, and that pattern will continue, then we're going to use this in our formula. So that would be the formula for that sequence. So some useful information for you. And there you go. Your assignment is right there at the bottom. This should actually be for B. Enjoy.